to today's webinar. This is the third webinar as part of the Digital Defender Cybersecurity Masterclass and Capture the Flag Competition 2000. Competition is organized by Cytec in association with India
Abhishek, I think your video and audio is
Private
breaking up.
Limited, Cisco CNR, Cisco CSR.
Maybe you can turn off your video so the audio might be better.
Yeah. Can you hear me now?
Yeah, I can hear you. Maybe you can turn off the video so the audio is better. It seems to be breaking a lot.
Right. So this is the schedule of the webinar series, which is the masterclass series. We are now in the first of which focus on web security. So this is web security and penetration testing part 1. And then we are going to have part 2 of this webinar, which is going to be held on the 16th. So we will now take a look at the exciting prizes that are on offer for the Digital Defender CTF 2023 participants. The top honors are the internship opportunities at partner organizations. However, shortlisting for an internship would involve meeting a few additional prerequisites by the candidate, and this decision will be solely at the discretion of the partner organization, whose decision in this regard will be final. In addition to this, there are 25 exciting prizes on offer, which total to a value of around 4 lakh rupees. There are 3 first prizes with a 40,000 rupee value, a cash component of 25,000 plus a Raspberry Pi plus a voucher for Hack the Box. 5 second prizes valued at 25,000 rupees, 10,000 rupees cash component plus Raspberry Pi plus a voucher for Hack the Box. And there are 7 third prizes, all valued at 15,000 rupees, which are a Raspberry Pi and a voucher for Hack the Box. And apart from this, we have a total of 10 more participating.
Abhishek, your voice seems to have gone.
So we will aim to provide an overview.
Abhishek, we can't hear you at all.
Explore further.
Kaushik, if you are hearing, please inform Abhishek that we cannot hear him. And
Can you hear me now?
Abhishek, but it's really, really broken. I think
We are all
we can
connected to
start
the
the
phone
session.
network. Yeah. Okay.
Yeah, I think we can start the session. Maybe if you are if you can give an intro for Kaarthik, we can
Sure.
start the session and then maybe give the overview towards the end.
Yeah. Kaushik, can you please move to the next slide? So web applications are the backbone of the world today, and many of the largest enterprises in the world depend on their web applications as the primary source of revenue. The explosion of a large number of exposed web servers to the internet has also meant that attackers and bug bounty enthusiasts are looking at these servers as an entry point to an environment. In today's webinar, Mr. Kaarthik Sivakumar will provide an overview of web applications on the internet and introduce some of the common technologies employed and showcase the common attack techniques to infiltrate these systems and its users. So the talk will also include live demonstrations of tools and techniques using real examples of web application. We are planning to conduct the next webinar on the topic of web security and penetration testing part 2 by Mr. Prapanch Ramamurthy, and we will announce the schedule for the same in due course. Please watch the SciSec website for more updates in this regard. It is now time for me to introduce to you our speaker for today, Mr. Kaarthik Sivakumar. Kaarthik is a principal engineer in Cisco's security business group, working in network and workload security. He has been in the industry for more than 22 years. He is an ACM India eminent speaker and has presented at multiple ACM chapters. He works with ACM and a few universities on improving cybersecurity education in India. Kaarthik represents Cisco at Telecom Standards Development Society of India, or the TSDSI, which is India's Standards Development Organization. And he was given the Outstanding Technical Contributions Award in 2020-21. In his free time, Kaarthik volunteers to protect India's cybersecurity stance for the citizens, for the enterprises, and for the government. Kaarthik, it is a pleasure having you with us. I will now stop sharing my screen and I request you please share yours.
Thank you, Abhishek and Kaushik for the introductions. Let me share my screen. Okay, so today we're going to talk about web security. As Abhishek was saying, websites are what everybody uses today. We do a lot of work with websites. We buy, we do online shopping. We give out, we check emails, we give out private information, we give credit card information. We do all kinds of transactions using websites, right? And so the security of those websites have become very, very critical at this point. We store a lot of information, or companies store a lot of our private information in their databases, and then they use it for whatever purposes that they do. Like, when we go buy something on an e-commerce site, we give them not only all the things that we want to buy, but we also give them our address, our email address, our phone numbers, credit card information, all of this to the e-commerce site. Right. And similarly, we do this kind of activity across a lot of other sites, and in particular mail, for instance, right? So we log into mail providers, and when we do log into mail providers, those email addresses are where we also get OTP or password resets and so on. So the security of all of these websites that we interact with is very, very key. Right. And so today you will see, if you read the news a lot, you will see that there's constant attacks on websites, right? And the data that is stored behind the website, right? And there are multiple kinds of attacks that happen today. We will go through some of it today and some of it in the next session on web security as well, right? So with that, I'll get started. So some agenda. So what we'll do is we'll do an introduction to how the web works, right? And what do we actually do? What are the kinds of protocols that we use and so on? And then we will start with an architecture review.
College degree. Vivekananda degree college. Alli. Ram Mandira.
I'm sorry, is there any question? Okay. So we'll do an introduction. We'll talk about a little bit of the architecture overview and some of the client technologies, and then we'll jump into the web security part. So web application. So normally we almost always interact with web applications using a browser, right? On a browser, we would go in and say www.google.com or any website that we really want to go. But the Google.com is not how the rest of the internet recognizes the servers. It's not that's not how the web applications are actually recognized underneath on the internet itself. So what actually happens is the client here, being the browser, when we go and say, I want to go to, in this case, let's say example.com, what actually happens is there's something called a DNS server, right? A DNS server is domain name service. The DNS server is the one that takes this domain, example.com, google.com, gmail.com, whatever the domain is, amazon.com, whatever the domain that we give them, it takes that address and then it returns back a response to that address, right? And that address is basically is an IP address. What you get is an IP address back. An IP address, IPv4 address in particular, is 4 numbers separated by dots, right? So you may have seen a lot of examples of these, these kinds of IP addresses. Normally, we never use IP addresses to interact with servers because it's very difficult to remember them. That's why we use something like Google.com or Gmail.com. They're very, very easy to remember and use. So when we go to the browser, we go to Chrome or any other browser, and you say Firefox or any other browser, and you say go to www.google.com, then a DNS request is sent out. And a DNS response comes back with the IP address, at which point our client actually then sends a HTTP request to that specific address. I'm not going below the HTTP request. I think in the last time in the network security side, we talked about a lot of protocols. I'm sure you must have, if you go through that, you'll see the many layers of protocols that are available. There's TCP, there's IP, and so on. So we'll talk specifically about HTTP only in this case, and not the protocols that come under that. So at this point, the browser is going to send a HTTP request to the web server, right? And the web server is the server that is hosting this particular web page. Let's say, again, Amazon.com or Google.com. Any of the services any of the websites that we normally go to is hosted by this web server, which then responds back with HTTP response. And this keeps happening a lot. I mean, it's not a single response that you get back. You interact with the website. So there's a constant set of requests and response that go back and forth between the client, the browser in this case, and the web server. There's a constant set of messages that go back, depending on what you click on the screen, or you type a form, you fill out a form, and you hit submit, and so on. A lot of different requests happen behind the scenes. And we'll look at some of these, how a form looks like and those kinds of details that's coming up. But this is the basic architecture that is there. Now, we talk about browser as a client, but you can also have all other kinds of non-browser clients. You can have programmatic clients, for instance. There is an application called curl. If you have used a Linux or a Linux-like systems, you'll see an application called curl, which is also useful to send to send a HTTP request and get response, and you will get all the data that comes back from the server, and then you can analyze them yourself, right? There are also other clients that are we can use for similar things, especially when you think about doing penetration testing and so on. Then you will find a lot more different clients that help you inspect the data that is coming back, right? Look at the data, what kind of data is coming back, what is happening, all kinds of details that we can look at. We'll definitely look at one or two of these kinds of clients and see how to use them in order to understand what happens behind the scenes. But typically, a normal user uses a browser such as Chrome or Firefox to access websites. From a web application perspective, there are multiple different components that are there, right? On the server side, there are, there's of course, there's a web service, there's a database that holds all of information. There's some file systems. There are lots of other services that happen on the server side, right? And you'll see more details of these in the next session. But today we'll focus on what's on the left-hand side, the client side. Right. On the client side, there's typically the browser. Again, that's what we normally interact with. There are a lot of local storage that happens. For instance, if I log into my bank, right, I do some transactions, then I close the tab, let's say, right, or I don't. I go back. I go out somewhere. I come back, and then I try to interact with the bank website. It may say something like your session timed out. Right? How does it know? right? How does it know that your session is timed out? How long is the session supposed to be kept active, right? And sometimes the server can then store data on your client side and then use that data again. For instance, you may have things like, you may prefer, let's say, dark mode, right? And now you can see a lot of the websites, they may have a light mode or a dark mode, depending on what your preference is, right? So that preference can be stored locally on your browser, and then you may, every time you go to the same website, it'll always show you the same kind of information, right? It may always show you dark mode, or it may always show you light mode, depending on what preference that you set. So all of these preferences are set using something called cookies, right? And we'll see more details about what a cookie is and what does it look like and so on, right? And of course, there's the authentication and identity part, right? Who are you? So when you log in, right, you typically would log in as a user with some password. Nowadays, we do a lot of multi-factor authentication. We send OTPs or we do CAPTCHAs and all of that part as well. So that's the other part of the client side, is all the authentication and identity parts of it. Right? And this is a typical web application architecture on both the server side and the client side. And as we said, there's a constant request response that happens between the two sides. So you're constantly exchanging information. Let's look at what some of these technologies look like, right? The very first thing that we don't directly interact with, but this is what the browser sees, is something called HTML, right? Hypertext Markup Language, right? So this is what HTML looks like, and you can see it's a language that is very different than, of course, what we communicate with, but it has a certain structure to it, right? So the HTML language basically starts by saying this is HTML, so that the browser knows what the language looks like. There is a body for this, right? The body basically says, okay, this is all the stuff that I'm sending as part of this. There are different kinds of markups. So what you see in these brackets are markups, right? So H1 means the heading of type 1, right? And then a P is saying that should be a separate paragraph, right? A button is where you can say, you'll have a button that says submit, and you can say click this, and you interact with the websites using buttons. You can have lists, you can have all kinds of different language. I've not put a lot of markup here. So there are lots and lots of different markups that are available with HTML, but this is how you define what a web page really looks like, right? So you put all of these things together, the browser looks at this and then generates a web page graphically that looks very graphically, right? And you can see the heading, the buttons, and so on. So just a question: are you all able to see my screen as well?
Karthik, we can see your screen. This might be a problem with the phone users. They might have to see the screen. Yeah, that's the thing.
Okay, got it. Okay, thanks.
It's visible, Kaarthik.
Okay, thanks.
Please go.
So this is HTML, right? We can, again, so this is how you would write a web page, right? And then the browser translates the web page and then presents it graphically. Okay. The second thing is called CSS. CSS is used to set, some kind of formatting to what you're doing. So for instance, if you want to set color, right? You want a text to come in the center, you want it to be red colored and so on, you set style, right? This is basically for setting style. So HTML is what you define what a page looks like. CSS is used to set style, right? There's lots and lots of different styles. You want to build a box, you want the box to be in the center, you want text to be above and below it, all kinds of things that you can do with web technologies. You can build it with CSS. So HTML and CSS together, build a web page. But the third part, typically the one that gives you the interactivity with the website, is called JavaScript. Right? JavaScript is another language, and JavaScript allows you to do all kinds of interactive things with the website. So for instance, you may see when I click the button, some text may change, and we'll see more examples. I'll show you a lot more examples of these, right? So when you click something, text may change, something may happen, so something may pop up. And does a lot of, so when you submit forms, for instance, you may do, it may do something in the background and like pop up something saying, you submitted this survey, thank you, and so on, right? So all of those things are really controlled by JavaScript. JavaScript provides you a lot of interactivity, right? In addition to interactivity, it also does a lot more things. For instance, you may be, if you've gone to any websites, like for instance, Twitter, for instance, right? Twitter, when you go to the bottom of the page, immediately the next set of tweets show up, right? Initially, they may show some set of tweets, and then as you keep scrolling down to the bottom, the next set of tweets come up. And then when you keep going down, next set of tweets come up. All of these are controlled using JavaScript, right? JavaScript allows you to do these kinds of very, very interactive functionality on the website. So these three technologies together, HTML is the language, the markup language where you set the text and you build all of these. CSS is for setting up the styles, and JavaScript provides you a lot of the interactivity that you get on a web page. These three together is how we build websites today. There's a lot more frameworks. I'm not going to go into this, and people have built, using JavaScript and using other technologies. They built like libraries and frameworks and so on that makes building the web technology, web pages much easier. A lot of people, hardly anybody builds web pages by hand, right? And very complicated web pages use a lot of these frameworks that allow you to bring everything together very, very quickly. Okay. So in general, the interaction looks like these, right? So this is your web page. Your web page goes across the internet, and it may access from lots of different services, right? You have a web server, the video server, ad server, everywhere, and then the web page puts them all together. And this putting them all together part is the key part of where a lot of the security problems come up, right? Because in a single web page, you're trying to access from multiple different servers. Then you start to see, how they interact with each other. And we'll talk a little bit more about, those kinds of interaction across different servers that we talked to, right? But this is typically what would happen. Okay, now let's talk about some of the very basic, foundation that we all, have been using a lot, but, maybe we don't know the details of some of these, right? So this is a URL, right? A URL is basically a resource, right? And this is something that we all type on a browser, and this is how we get to the specific server, right? And there are lots of different parts to this URL. So for instance, the first part is a protocol. HTTP is the normal protocol that we've been using, hypertext transfer protocol. Nowadays we use HTTPS. The S stands for secure. The secure basically does encryption between the client and the server so that the traffic is not sent in clear text. When something is sent in clear text, then people can easily see, what data is being sent. They can read your login and password. They can read your credit card information. So hardly any servers today use just HTTP, right? Most servers use HTTPS, the secure part of HTTP, right? So that's the very first part. That's the protocol. Then the next is the server itself, right? Which is the server that we are going to. The third part is the protocol, is the port, right? So the port is where the service actually runs. And this, if you go through the network, side of this, then you'll see there's, different ports where services can run. Typically, HTTP runs on port 80 and HTTPS runs on port 443, but we can have the services run on lots of different ports, right? Any port that we really want to do. The fourth part is the path. You will all have seen this. You can do a slash and then you can get some information. That's all in the server side. They're all directories, right? And within the directories are folders. There are different files, and so that's what this is. So that you will see a lot more of when we do the server side in the next presentation, right? The last part is the arguments, right? So you would have probably seen this a lot where, let's say you go to an e-commerce website, and then you do a search, right? And then when you do a search in the URL, you can see that there will be a search equal to, and a bunch of strings will be added to that search, right? And that bunch of strings in the search basically is how the server then looks at that set of strings and says, oh, you're searching for, let's say, a jacket, or you're searching for a shoe, or you're searching for whatever it is, right? And all of that is captured in these arguments here. So in this case, what I'm doing is I'm looking up a car info, right? I'm saying the model is a Swift and the year is the 2023 model Swift, right? So this is basically how we interact with servers. Now most of us do not directly enter all of this information. We may just enter the server information, and then we interact with the website. So we go into the website, we fill a form, or we do some search, and then from there, these other parts of the website, the URL automatically get filled in, right? And then they go back to the server. The server looks at these arguments and says, oh, you're looking for a Swift from year 2023. It sends that information back, and then you see a page. Now, all of this is very important because these are all the ways that, like in arguments, for instance, are all the ways that you can try to penetrate the security of the server. And we'll see how to do some of that part. right? We will take a look at an example where we can take this URL, right? And then take those arguments. And what if I replace these arguments with something, right? If I replace this, Swift in 2023, let's say 2023, let's say, what if I do year 2050? We're not in the year 2050, right? There is no Swift for the year 2050. There's no model of a Swift car for the year 2050. But what if I did the year 2050? Right? What if I, give Swift as SWIFT, but let's say I make a spelling mistake, right? What happens in that case, right? So we can do all these kinds of testing, right, and then see what the result is. Now, sometimes, many times, the server is very clever and it'll block those kinds of things. It may tell you that there's no such model, or there's no such year. You're looking for the wrong thing. It may give you that kind of information, but sometimes when you give change the information that you give in the URL, the server may actually give you something that it is not supposed to give you, in which case you've just basically bypassed potentially some security in the server, right? You may get some information that you're not supposed to see, and so on. So that's really what the testing and the penetration testing part of what we're going to do is. So here's an example of a URL. Again, we all interact with this a lot, but we may not know the different parts of what constitutes a URL. Okay, let's look at the HTTP protocol itself a little bit, right? So we looked at this as the URL, right? Now, when we give this URL, then we get some data back. So in HTTP, there are multiple types of messages. The first message type is called GET, right? And as the message says, we are asking for information because the browser is saying, get me this information, right? That's what it's saying. Get me the information for the model Swift for the year 2023, right? And that's all it's sending. It's basically asking for this data. Note that this does not change any data on the server. It's not like filling a form, right? When you fill a form where you say, you register for an event, for instance, you're actually filling something and sending. This is not what that is, right? You're just simply getting a data. So I can look at the data that is being sent by the browser and what the response is coming from the server back, right? So I can see that the browser will send this as the request. It will send a GET request to the server and say this is the URL that was sent, right? And then HTTP 1.1 is a specific protocol version that was sent. This is the host name that we're sending it to. And this is the user agent. User agent is basically what is the software that I used to make the request, right? Typically, it'll say some browser software. It may say Mozilla for Firefox. It may say Chrome, or in some cases, if you're using a programmatic word tool like, let's say, curl, right? It may actually specify a different user agent. You can even specify your own type of user agent if you want, custom ones that you want to do it, right? And see what the response is. So when you make a request like these, then you get a response back, right? In this case, it's the server is saying it's running HTTP 1.1 version also. The number 200 is a code, right? It's a response code. And the code basically says that if the response is okay, right? There was no problem in servicing this specific request. And here's the content length. I'm sending you 1423 bytes of data in the form of a HTML page, right? And then after that comes the whole HTML document, right? Which the browser, if you're looking at it through a browser, the browser will just simply look at and present all of this information on it, right? But if you look at the internals, this is what is happening. So what you can do is that you can connect to the server using specific software, and you can send this kind of information yourself. You can type get car, all of the stuff that is listed here, you can actually do it manually, right? Instead of going through the browser. And typically for penetration testing, that's the kind of thing that we would want to do, right? We want to be able to directly interact with the website, and then the website will respond back to us with this, and then we can analyze that and say, okay, this is what is happening, right? And that kind of things. So that's the GET protocol, right? The second is called POST. POST is how we normally send data to the server so that the server can then store it and do something with it, right? We are typically, for instance, this is the normal way of filling out a form, right? When you go to some website and they ask you to fill in a registration information for an event, right? Let's say, there's some concert that's going to happen, and you're going and giving your name, your address, your phone number, and you're going to pay some money. You fill out the credit card information, all this stuff, and then you finally say submit. When you do that, then it goes out in the form of a post, right? And this is what a post actually looks like. So if you see in the post, right, it first says this is a post message, right, to this specific URL, again HTTP protocol, right? This is the host that you're sending it to. Now the key part is this field and value. right? In this case, if you are doing a registration for an event, for instance, the field 1 could be the name, and value 1 would be my name, Kaarthik, right? And field 2 would be address, and then the value would be my address, right? And so on. How many fields there are for each of the field that was there in the form, I can, the browser will create this long line, right? And then send them all out to the server, right? Now the server at that point can respond with 200 success we saw, but there are other error codes that it can, response codes that the server can respond with. For instance, there is a response code of 401, which means that it's unauthorized, right? You are not authorized to send this information, which means that you probably have to log in first, right? When you get an unauthorized, the browser will tell you that you're not authorized to do this, at which point, it may ask you to log in, or you may have to, first register with the site itself and so on, right? So this is a post, right? This is typically, again, how data is sent to the server so that the server can store the data or modify its own data, right? In order for a server to modify its data, you need to send a post request. So we looked at one type of request, which is, as you can see, we said field 1 has value 1, field 2 name is equal to Kaarthik, address equal to my address, and my email equal to email, and whatever, right? And there are other ways to do this also. For instance, you can send messages in a format called JSON, right? If you send it in a format called JSON, then instead of sending it as field 1 equal to value 1 ampersand field 2 equal to value 2 and so on, you send it instead in this format, right? It's interesting to know all of these because many different servers take data in different formats, right? And the browser can send them in some format, the server side can take it in a different format and so on. And so we have to know what the format is so that we can go and modify these values in order to do our penetration testing, right? Based on the format that the browser is sending, based on the format that the server is expecting, we can change these values, right, to the right ones so that we can experiment and see what happens. For instance, if I say name, and instead of saying Kaarthik, right, I give it with all kinds of random characters. Does it break? Right? What if my address was not in India? What if I give a foreign address? Does it break? Right? And so we can experiment with all of these things. What if a phone number, instead of giving 10 digit as a phone number, what if I give 12? Right? Does it break in some way? A browser itself may not accept these, but when we, programmatically try to break in or do some penetration testing, we will be able to see that, what happens if instead of 10 digits, if I give 11, if I give 9, does it give me back an error, and so on. So it's interesting to experiment and see what happens. Now I pointed out another response code here, which is 403, which is forbidden. So which means that you, even if you log in, right, you do not have access. You are not allowed to see this, right? So it's forbidden. Okay, so again, you can see a lot more of the server's response, right? So when the server responds, it will give you a lot of information. So in this case, it's telling you that its content type is HTML. It's 55,000 bytes of data it is sending you back. It is telling you, again, you may sometimes hear this, when you are not able to access something on a website, you may, if you go Google what to do, they'll tell you, clear your cache, right? If you clear your cache, it may work. So basically what is happening, the server is telling your browser to cache a web page for a certain period of time, right? In this case, for 300 seconds, cache the web page, right? So that's why we have to go and you get, old information, you get outdated information, then you have to go and clear out the cache, and then things may start working again, right? So this is what a full server response. Well, this is not full. There's a lot more information that it can send, but this is a lot more, detail on what kind of response you may get back from the server. Now, again, all of this is interesting because you can try to modify what the server is sending, and then you can see, test with that and see what happens. So one of the key things we talked about, we looked at the URL and we said, all of these URLs are, has different parts and pieces to it. And the reason why we look at it, and one of the key security parts in the web is something called same origin policy. Now, what used to happen is that I go to a website, right? Let's say I get an email from, somewhere and some spam. I click on it and then I say, and it tells me, you have to pay your electricity bill. Click here to pay your electricity bill, right? And so I click on it, and it takes me to a website that I do not know. I don't know what the website is, right? It could be, badelectricitybill.org or .com, right? Let's say. But what it's trying to do is from that website, let's say it is trying to load your government website's data, right? And that is not allowed by the browser. So the browser has to now decide, right? You're on a bad website. It is trying to pull information from some other website. Is it allowed to do that? On a single page, can I see data from multiple different servers or not, right? And so that's called same origin policy. The same origin policy is very, very important as a security matter, right? For instance, let's take a look. So here's a web page, store.company.com/dir/page.html. I'm looking at this page, right? Now this page gives me some bunch of HTML information, right? It tells me on this store, on this, let's say it's an e-commerce site, right? On this e-commerce site, I have information from, I have some jackets, I have some shoes, I have, all kinds of different things that are there. But what I'm trying to do is I'm trying to pull these images of a jacket from a real jacket on some other site, right? I'm trying to pull this image of a shoe from another, shoe that is there on some other site. Can I pull this information and show it on my web page, right? Now that depends on the policy, right? And this is what the browsers typically follow. So let's say I'm on store.company.com, right? I pull something from store.company.com, but from some other page, some other directory structure, that's allowed because it's the same server, same protocol, right? And the same port. Everything has to look exactly the same. Then I can pull information from different folders, different directories. But if any one of them is different, let's say I'm on HTTP, I try to do anything with HTTPS, right? That's going to fail. If I'm on HTTP, but look, there's no port specified here, which means this is port 80. I pull something from port 81, that's going to fail, right? I'm on store.company.com. If I go to news.company.com and try to pull some information, that is going to fail. And not just news.company.com, I can't pull anything from anywhere else. So browsers use this as a very important way to provide security so that you don't end up in a bad site, right? Let's say you don't end up in a hacker's website, right? But the hacker is actually pulling your information from your bank, right? Or the hacker is pulling information from your electricity or your government information and presenting it on their own website. They cannot do that, right? And the same origin policy is what protects us in that respect, right? Same origin policy prevents this kind of information from coming in. But this only is very limited kind of security. There are other ways that this kind of security can be broken, right? And we will take a look at it very shortly. Okay, HTTP and HTTPS. Why did we go to HTTPS? Right. One of the key things that you have to see is on the left-hand side here you have a browser. On the right-hand side is a server. This, in the middle you have something called man in the middle. Right? That's a person who's sitting in between your browser and the server, and he's trying to watch what's going on. Now, normally with HTTP, what happens is this is how the message looks like. We saw this message before, right? It's a get message. I give my username and I give my password and I'm asking for something, right? The man in the middle is now able to see this. It's coming in as clear text, right? It's coming in as clear text. They can see this message and then, it gets forwarded, or they can even modify it and forward it to the server, right? So they can modify this information, forward it to the server. The server responds with, let's say, a bank balance, right? I ask for my bank balance, I get my bank balance back. Now the man in the middle can see this information too, right? And then they can send it out. So, and then it gets forwarded to me, or again, the man in the middle can modify it and then send it to me, right? This is the problem with HTTP, right? But with HTTPS, what happens is that what gets sent is completely encrypted. The man in the middle cannot see it, right? There is a lot more detail that I'm not going into at this point, but there's a lot of detail about how keys are established between the client and the server. There are certificates that are set up. Yes. Yes, any question?
Yeah, can you hear me?
Yes, I can. Hello?
Hello.
Yes, I can hear you.
Yeah, so we are getting messages from the participants that they can't see your presentation. So instead of sharing your screen, can you share specifically the presentation? Even Prapanch is saying he's not able to see your PPT.
I see. Okay. So 1 second, let me try that.
This looks specific to people that are joined from their phones, not from their laptops. for some reason.
Okay. How about now?
Yeah, now it's visible. Kaarthik.
Okay.
Okay, people on the phone
Okay.
should be able to see it now. Go ahead, Kaarthik. Continue. Thank you.
Okay. So with HTTPS, what happens is the data is sent encrypted, right? So the man in the middle cannot see it, and the return data is also completely encrypted. That's why all the websites have moved to HTTPS. You should be able to see this with the green lock icon that usually shows up in the browser, right? And the green lock tells you that that is HTTPS. And so the man in the middle cannot see this. Okay. So I want to see, just show you a little bit of some tools, right? And so let me share a little bit more stuff. So I've got, okay, one. Sorry, I just have to select a few things because I'm sharing application by application. So, okay. So there are lots of different applications that you can use to see what is happening in between, right? For instance, this is, can you see this now? I'm sharing an application called Burp Suite. Is that visible?
Yes, I can see it both on laptop and phone. Yeah.
Okay, very good. Okay, so this application is called Burp Suite, right? And this application is very interesting because it can sit in the middle of the browser and the server, right? Between the browser and the server, it can sit in the middle and it can intercept messages. You can modify what is happening. You can see what is happening. You can also modify the messages that go through, right? So then you can start playing with it, right? You can send different kinds of messages. You can see, what happens in the middle and so on, right? So that is something that you can do. Okay, so in here,
Kaarthik,
so
the screen size or font is a little bit small. If you can zoom in,
I know.
possible. Or
I don't. Burp Suite itself is like this. Actually, I'm not sure how to set the thing on this. Yeah, I know it is kind of pretty small. So if you can do zoom on the WebEx, maybe that helps. So
yeah, so people, you can zoom on the WebEx, which makes it a little bit better.
yeah. Okay. So so there is a proxy and there is a browser that comes as part of Burp Suite, right? And so what happens is when you use this browser, then you can see, you can go to some web page and you can see and you can interact with the web page while you're also seeing what messages are happening here. So for instance, so I went to the proxy tab, right? There is an intercept here. I've turned it off. I'll explain what the intercept does very shortly. But when you browse from within within this Burp Suite's own browser, then you can see there's a history. I've been browsing using Burp Suite a lot. So you can see there's a history. You can see there's a request was sent out. Here's a response that came back, right? You can see all of these messages that flow. So as we talked about, you can see this message is a get, right? Get message was sent to this specific host. There's a lot of user information. So this browser identifies itself as a Mozilla, right? And then you can see there's a, what kind of information it accepts, right? It accepts a HTML, XHTML, and so on. And so it does a bunch of stuff. In response, right, when this message was sent out, the server then responded by saying, hey, I can speak HTTP version 2, not just 1.1, but I can actually speak HTTP version 2, right? 200, okay. So yeah, I got your request and everything was fine. Here's the response back. The response is of type content text HTML, right? In addition, you can see that it's setting a cookie. You can see in here the server is doing a set cookie, right? So it is setting a cookie and saying this session is some arbitrary string here. That string is not readable to us, but that string is readable and understandable by the server itself, right? So the server can understand what that string is, and what happens is that this is how banks, for instance, set your session, right? So what happens is the banks are basically saying, this is my session. When you log into the bank and then you go to other tabs, you do a bunch of things, and then you come back to the bank, it still remembers, right? And sometimes what happens is you may, in some web servers, you may even close the tab, right? You close the tab, you open another tab and go to the same page, and it may still remember you, right? It'll still remember you completely. That's because of this cookie. right? This cookie is a session cookie, right? And this cookie is what tells you who you are, who tells the server who you are, right? And so that's how they recognize that you've logged in again, right? And there's some additional information about the cookie itself that we will talk about in a little bit, right? And you can see that this is all the HTML that came out of that, right? So there's HTML here, and the browser takes this HTML and parses it and creates this web page that you finally see on your browser, right? So you can basically go back and you can see a lot of these requests and responses that were there. For instance, this specific request is a post request going to google.internal. It's basically a REST API call, and it's doing a bunch of things. So here's some message that it sent, and in response, I got some totally binary response back. Right, this is all binary response. This needs to be parsed and handled in some way, right? So this was an API call that was made, and so on. So you can see if you play with Burp Suite, you can interact with lots of different web pages, see how all the different web pages are built. So this is, let's say, this is we're making a call to DoubleClick. DoubleClick is part of the ad networks, right? So that's what this is, and here's a font that we pulled from Google. Right, so some websites like to use specific fonts, right? So that's what this is. It made a specific font request, and so the font request here is Roboto, right? Roboto is a common font that a lot of web pages use. So it made a request for a font, and in response, it got a font back. All of this binary data here is actually font information, right? And then this font information is used for the web page itself, and so on. So with Burp Suite, you can actually see how web pages are built. What kind of request and response goes out. All kinds of things you can experiment with Burp Suite, and you'll be able to see all of these information. Okay, so Burp Suite and the browser that comes with Burp Suite, right? And we will play with it a lot more, right? Now let's take a look at the intercept option in Burp Suite, right? So let's say I turn intercept on, right? So when I turn intercept on, what happens is that if I let me create a new tab, and I'll go to google.com, right? Now what happens is that the Burp Suite has intercepted. If you see the browser, I'm not able to go to google.com, right? It's not going there yet. That's because Burp Suite has intercepted this request, and it's waiting for you to do something with it. I went to google.com. There's a cookie that it has. It's sending a cookie back to google.com. It's doing a bunch of things, but this request is not gone yet, right? And what you can do at this point is you can do a few things. You can drop this packet, right? So which means that Burp Suite is actually sitting as man in the middle, right? It is sitting in the middle of the browser and the server, and then you can take some action. So for instance, you can say drop the packet, right? Drop the packet and let's see what happens, right? Or you can take some action on the packet, or you can just simply forward the packet, right? Forward the specific request. So that's what we're going to do. We're going to forward this request. When I do that, at that point, you can see there's a lots and lots of requests being sent by in order to go to google.com, there's a lot of requests being sent. So you can see now how every request is being sent, right? Browser is doing a lot of stuff to send requests, and you can actually see slowly the web page is starting to show up, right? You can see google.com show up little by little, but so many requests are sent between the browser to Google in order to get to a single web page, right? And so you can keep doing forward, you can keep watching what's happening, you can do all of these information here. Right, so okay, I'm going to turn off intercept so that all the messages get sent out. Right, and so you can see, you get the Google web page, and then it says sign in, and you can do all kinds of things. Okay, so this is what
Burp. You can, if you want to increase the font size, you can go to the settings page.
Okay.
User interface display, and there's a font size right there.
Got it.
Yeah, thanks.
Thank you. Okay, I hope this is better.
Yes, much better.
Okay, very good. So just to repeat, right? In the intercept, there's an intercept off. You can turn intercept on, and then you can go to any website that you want. And when you do this, I'm going to just reload this website, and then you can see the data show up, right? You can see all this data, and then you can forward, or you can just drop the packet, or you can just turn intercept off, at which point all the requests go. If I go back to HTTP history now, I can see all of these messages that were sent out, right? So I can see, here's google.com, right? This is the message that was sent out, all the different messages and the response that came back, right? Each of these is shown here. I can see all of these items that show up, right? So this is how I can use Burp Suite to sit as a man in the middle between the browser and between the server, and then see the exact messages that are getting sent out. Right, so that's what's happening. And you can do a lot more inspection. You can look at attributes. You can look at the cookies that were set. Right, there's a bunch of cookies that were set. Some headers were set. Right, all kinds of information, and you got some response back. And you can do all of these information, and you can inspect all of these values here. So it's very useful, right? It's very useful in that respect, to understand exactly what's happening. Another tool that you'll see a lot of people use is called curl, right? Let me bring this up, right? Okay, before we get to curl, we talked about DNS, right? We said, if you give google.com, it actually has to be translated to an IP address. There's a utility on Linux and Linux-like utilities. I'm using a Mac. Even Mac has this. You can use a utility called dig, right? It's called dig. Let me turn up the font on this also. So dig, right? Now dig is a way to give a domain and then get an IP address back. So in this case, I'm doing google.com, right? And I get an IP address saying this is the IP address of google.com, right? I can do the same for, let's say, yahoo.com or any other websites. So Yahoo has these two IPs and so on, right? So this is what happens under the cover when you go to the browser and say I want to go to www.yahoo.com. It sends a DNS request out exactly like how dig does it, and then it gets these IP address back, which is then used to then send an HTTP request to this IP address and say, send me the HTML page for this specific website. Right now, once I have this information, I can run an application called curl. Right now, the idea of curl is that I can do just like a browser does. So I'm going to go to www.google.com, right? And what is going to happen is it's going to go to google.com, send a request, and then get me back the response. And you can see this is all the stuff that Google sends out, right? I said curl and then gave all the stuff, and then Google sent me back a doc type HTML, and it gave me all the pages. It gave me some JavaScript as well. You can see there's a function here, right, with some JavaScript in there. It'll send me, look at this. You can see the document. It's adding an event listener. Here's the submit button. So everything that you see on the web page, you just get directly as this HTML, JavaScript, and CSS, and all of these things put together. Right, it's very interesting just to pull this information, then look and study it. Right, if you want to study it, you can do that. Right, and so curl is another way that you can communicate with websites. You can even do post. You can send messages back. You can publish forms using curl. You can do all kinds of stuff. You can also experiment with REST APIs. If you know what REST APIs are, these are APIs that are used over HTTP to communicate across applications. Right? You can use curl for doing this. And curl has a lot of options that I'm not going to go to, but each of these then internally expands out a lot of different ways that you can interact with websites. Right? So you can do all kinds of things with that. Yeah, so HTTP post data, for instance, is how you can send form information to a website directly from curl without using a browser. But you can do all kinds of interesting stuff. Similarly, there's another application called Postman. Postman is typically used for doing working with APIs. I mean, again, REST APIs typically, right? You can interact with web pages or web applications using this. We're not going to do too much of this, but it is there. And if you're interested in doing more with web applications using APIs, Postman is a very interesting application that you can try to work with. Okay. So we will use some of these applications now as we go through in this presentation. We'll show you a bit of how all of these work. Okay, let's go back to the presentation. So we did a bit of hands-on. We'll also do a little bit more when we go through each of these different items. So I'm also going to talk about. I'm probably not sharing. Sorry, let me just share one more application. Okay, so there is going to be a CTF, right? All of you are going to participate in a CTF, and I think last week also as part of the network, topics, Pico CTF is something that you can use for practicing, right? And there's a lot of different categories. So in here again, if you go to Pico CTF, and there's a web exploitation as a category. If you go to the web exploitation, there's a bunch of different challenges that you can use, right? And so you can look at all these challenges. You can, play with them. You can, solve them. Of course, that's the idea, right? This is the way you can get a lot of practice for the CTF that's coming up later, right? For the CTF, Pico CTF is a very, very good way to go and get some experience solving these kinds of challenges. So let's take a look at the first one here, right? It's called Get Ahead, right? So I click on this. And this is the challenge, right? Here's a website. Here's a URL, right? This is a URL, right? So it has a HTTP protocol, a server, and a port number, right? And it says, there's a flag, right? In Pico CTF, a lot of the flags look like these, right? They look like Pico CTF, and then something is in between, right? This is what a flag looks like. So we need to find those flags, right? And that's the idea of the whole challenge, is to find those kinds of. Actually, I use the wrong parenthesis. It's this curly brackets, right? So you have to go find that specific flag. That's the idea of this, of Pico CTF and of any CTF. There's typically some flags that you have to go figure out, right? So in this case, it says, right, find a flag being held on the server to get ahead of the competition. Now, there are a couple of hints as well, right? You can look at the hints. Maybe you have more than 2 choices, and the second hint says, check out tools like Burp Suite to modify a request and look at the responses, right? So all these options are there. So I'm not going to solve this specific example, but maybe a little later in the thing we can definitely look at solving this. But take a look at it. We already looked at 2 different messages that are there in HTTP. One of them is a get, the other one is a post, right? So it says get here, right, and then ahead, right? Maybe it's worthwhile seeing what other kinds of messages are there in HTTP and see if one of those messages will be helpful for you in solving this, right? I think that is a good way to think about it. So take a look at it and see, go through the HTTP protocol and see what other messages are there, and you can take a look. Now let's just go to this specific website. I'm going to click on this, and this is what it says. It says choose red, choose blue. I choose blue, right, and the screen turns blue. If I choose red, screen turns red. So the website itself doesn't seem to have the flag there, right? I go to the website, I don't really get any flag there. I can, go to the browser's, web inspector or the developer tools, as it is known in some browsers. You can go look it up, and then you can see, are there anything that is coming up as a result of this, right? So I see there's really a cookie, but there's not any value to it. There are lots of different elements. So for instance, I can see this is the HTML page, right? And so on. But I don't see any flag here directly, right? I see HTML head and there's a red and so on. But I don't really see anything that looks like a Pico CTF and a flag. So there's some more work that we need to do in order to figure out, what the flag is in this specific challenge, right? So think about it, and we will definitely come back to this. We'll try to solve one or 2 of these, and then we'll see, how that works. Okay. So, but Pico CTF is very, very good way to train yourself for the coming challenges, right? So get ahead is the first challenge. It's also, you can look at the points. It's like 20 points, definitely a very easy one. You just need to know a little bit more about HTTP in order to solve this. Okay, let's go back to the presentation. So we're going to look at the next step in here, which is cookies, right? We talked about this. Cookies are used to store specific data, right? There can be session data. There can be customization. In some web pages, you can say, I want the minimum font size to always be, 17, right? Because, I have trouble reading and I always need the size to be some specific size, right? So you can set all of these things, and then these are all set as cookies in your browser, right? You can look at the, or there's maybe shopping cart information. There's all kinds of information can be stored as cookies, right? Typically, they're used for storing sessions with an expiry date, right? There's an expiry for that cookie. So you can see this in the bottom. You can see the server will send something like set cookie, and then it sets the theme as dark, and another set cookie that says this is the login information, and that expires on Friday, 16th June, 2023 at the specific time, midnight. Right? Which means that now, if you log in into a bank may set a session like these, right? And it may also set an expires, right? That is the reason why you can close your tab, right? And then come back, create a new tab, right? Open a new tab and go to the same website, and it still remembers you, That's because it set a cookie. But some days what would happen is, if you notice, after some point, it doesn't remember you anymore, right? It doesn't remember you and you have to go back and log in again. And that's because of the expires, right? The expires tells the browser that the cookie is valid for such a period of time. If you go back to that website, right, it will, so on the client side, for instance, when you go back, it will basically say, this is the cookie that you had set the last time, use the same, some information from this cookie, right? So when it expires, then at that point, the browser will no longer send that information, right? And that's how you know that you have to re-log in into the web page. So cookies are used to manage this kind of information. Okay. Now, the most important or the easiest kind of attack that you can look for is, can I hijack those cookies? Remember that cookies are used for storing session information, right? If I can hijack those cookies, then if somebody's cookies, let's say I log in into some website and I got a cookie. Now, if you can take that cookie from me, right, then as far as that website is concerned, you are me, right? You can basically behave like me, right? If you can hijack my cookie, then what happens is you can do whatever I can do on the website. If it is a bank website, for instance, and you take my bank history, let's say I'm just picking an example. I have an account with HDFC Bank, and I go to HDFC Bank, they set a cookie. Then the next time, right, if you can take this cookie from me, then you can go to HDFC Bank, and HDFC Bank will think that you are me, right? At which point they will let you go in. You can, send out, steal my money effectively, right? You can steal my money. So cookies are very, very important, right? And so cookies are used as a way of specifying authority, right? If you have my cookie, as far as the server is concerned, you are me, right? That's the kind of authority that cookies can provide. So one of the key attacks that you'll always see on the client side is, how do I hijack your cookies, right? How can I hijack the sessions using the cookies that were set? So which is the reason why a lot of the times the websites, use specific paths or domains for setting the cookie. So you can't basically use my cookie everywhere, right? So in gmail.com, they may set a cookie that says that this cookie is allowed on all of google.com. So if I log into gmail.com and then I go to google.com or maps.google.com or any other part of google.com, it'll still recognize me as Kaarthik, right? Because the cookie is set that way. Right? And so you can basically use the cookies to restrict, where that cookie can be used. Session hijack using cookies. The very first step, do not use HTTP. Right? Again, man in the middle. We just saw that, with Bob suite that we're using. And you can also use secure. Right? You can use a secure attribute. Now let's go back to Bob suite. Right? And if you look at the cookie, you will be able to see that. Where's the Google? Okay. So you will be able to see that Google sets a cookie with secure attributes set on it. I can't find it now, but you will be able to clearly see that it will do a set cookie, but with the secure attribute set on it. If the set cookie is done with the secure attribute, okay, right here, you can see this. This is a cookie, right? It basically says, it sets an expiry. It says up to 13th July. So for 1 month, if I try to go to Google and log in for 1 month, it's basically going to remember me. There is a path, right? There's a domain, everything on google.com. You can use the same cookie. It says secure, right? Which means that the cookie is not available if I come through HTTP, right? It's only available if I come through HTTPS, right? That's very important, right? So let's go back to this. There's a cookies challenge here, right? Very similar, right? I look up the challenge and I have to use cookies to do something, right? Now let's take a look at this. I'm going to go to this website. This is the Pico CTF, and it says, welcome to my cookie search page. See how much I like different kinds of cookies, right? Okay, so now I can say, which is snickerdoodle. Let's try snickerdoodle, right? And it says, oh, that is a cookie, but it's not very special. I love snickerdoodle cookies. Okay, what if I try, let's say, and then I try Oreo. That doesn't appear to be a valid cookie, right? And so this web page is here, but we need to know, how to get the Pico CTF flag out of this. So let's again go to the web inspector, right? And let's go to storage, and then you can see cookies, right? So you can see that this website is setting a cookie value of -1, right? Now, if I reload this page, it basically uses -1 to present this cookie value of -1 to do something. It presents this specific web page. What if I change the cookie? I'm going to edit the value of this cookie, right? I'm going to say 10. Okay. And then let me reload. So what I've done now is that web page set a cookie, right, of value -1. Then what I did was I went in and changed the stored value from -1 to 10. I'm going to reload the page. When I reload the page, what happens is that server is going to ask for the cookie from my browser. The browser is going to send a cookie value of 10, right? When I do this, look at this. It says biscotti cookies, right? A cookie value of 10 change the web page to biscotti cookies, right? Okay, that's very interesting. So what if I change this to 11, right? And let me reload the page again. It says butter cookies. So it looks like the cookie value is changing, you know, what text shows up here, right? So I'm going to, let's say 5, right? Peanut butter cookies. So each of the times that I change the value, right, it shows me a different one. Remember, what I'm looking for here is a flag that looks like Pico CTF and then curly braces and something in between, right? That's what it should look like. So what we need to do then is keep changing this cookie value until we get the flag, right? Instead of saying, I love peanut butter, I love, you know, all kinds of different cookie types, we can try different, you know, cookie values and then see if that works, right? And that's one way to try to solve this problem. Again, I don't know what the solution is. You can try it out. That's what this is going to be like. Okay. So we looked at cookies. Cookies are, as we said, very, very important, right? Cookies are really, a lot of the times, what a lot of these attacks try to do is try to steal your cookies or use your cookies to make some action, right? Make some action on the website. One of the key types of attacks that you will see is the cross-site request forgery, CSRF, right? CSRF, cross-site request forgery, right? Let's see what that is. Now, this is an email. You could say we got an email, let's say from some place, right? And the email basically says, delivery of your order was canceled because of something. Please, click this form and fill it back, send it back to us, right? And if you were, having a business with this particular website, right? Let's say Costco wholesale, you're going to think, oh, maybe, something is wrong, right? This particular order of mine didn't seem to work. Let me go and figure it out. A lot of us know that now we're all very tuned to this, right? We know that this kind of thing is most likely some kind of fraud, right? They're sending you this is a phishing email, right? This is a phishing email. They're sending you this just to get you to click on this form and get you to fill something up, right? That's exactly why they're trying to do this. But now let's go a little bit inside of this and see what is actually happening behind the scenes a little bit, right? Now, so I don't know this is fraud, right? I'm going to go click on this form. I think this is a legitimate email. I'm going to go click on this form, right? And behind the form is going to be something, right? Behind the form, now this form, when I click on this, it's going to take me to, let's say, my.hack.com, right? It's going to take me to my.hack.com, right? Now, in this form, it may ask you for a bunch of stuff. It may ask you for your name and all kinds of stuff, but there's going to be a few hidden items here, right? There's a few hidden items here. You can see the hidden item is name is 2. There's a hidden item, name is account and some account number, and another hidden item with a name amount that basically says 1,000 rupees, right? So this is basically what is it trying to do is it's created a form, right? You don't know what the form is actually like. You may just think you're filling your name and something else, but this form is actually sending this. When you hit the submit button, it's actually sending this form to hdfcbank.com. Right, it's sending this to hdfcbank.com/transfer, and it is setting the values to, from my account, right, send 1,000 rupees to this hacker. That's what it's doing. And when I hit the submit button, it's basically going to go and post it to hdfcbank.com. I did not go to hdfcbank.com. The site I went to is my.hack.com, but my.hack.com has the specific form in there, right, where internally it is basically just doing this. Now, why is it doing that, right? Remember, if I were logged into hdfcbank.com, then hdfcbank.com would have set a cookie, right? It would have set a cookie on my browser so that when I try to log in back into hdfcbank.com, it recognizes me and says, you're already logged in, and it may just show me my account page directly, right? It may directly show me my account page, right? So the cookie is very, very useful that way. But what this form is trying to do is trying to use my existing cookie. Let's say I was already logged into the bank. It was trying to use that existing cookie to take some action. Now, I don't know if HDFC Bank actually does this. I just use this as an example, right? And this is obviously should not be working, and I don't think it'll work. So, but this is just an example, right? If there were a form that HDFC Bank had where, you can use that form to send money to somebody, what this is doing is through using the hidden values, it's basically without my knowledge, I just went to my.hack.com. Without my knowledge, it is sent under the covers. It is sending a message to hdfcbank.com to transfer money to that specific account, right? And it is using that through cookies that were set by hdfcbank.com, right? So this site is actually taking you to my.hack.com. You go there, and under the covers, it is sending a message to hdfcbank.com. That's called a CSRF, right? Cross-site request forgery. So why is it called CSRF? Because I went to my.hack.com. The message actually, when I filled the form and hit submit, it is actually sending a message to hdfcbank.com. So cross-site, from one site, it is sending it to another site, right? And it is doing a request forgery, right? It's doing a forgery, right? Of the request, right? So that's CSRF, right? Cross-site request forgery. And the key thing that it's using here, this is what it's doing, right? I basically go to my.hack.com, right? It sends me a form, fill this form, right? I fill this form out, I hit enter, I hit the submit button. At that point, it is actually sending that form. My.hack.com is sending the form to hdfcbank.com, right? And says, send me money, right? And with the cookies, the most important part is my cookies, right? And at that point, hdfcbank.com is sending the money to that account and says, I did it. Your money is gone, right? So this is a CSRF. Okay. So this only works if you're logged in, right? If you're logged in into your bank, if you're logged in into any other website, then this kind of thing actually works. Obviously, banks, that's the reason why they don't do these kinds of things. They don't, if you close your tab, for instance, then the bank automatically logs you off, right? Those are the kinds of security protections that they use. So you should not really, this kinds of hacks should not really work with the banks, right? But there are lots of other websites where these kinds of things can happen, right? Where a website may keep track of you for a month. We saw that with Google, right? They set a cookie that basically says for 1 month that cookie is valid, right? Now, if Google does not take appropriate precautions, then some other website, right, can use the Google cookies to do something on my behalf. They can behave like they are me, right? And then they can try to do something. That's very interesting, right? So that's the thing. So this always happens when cookies are used to keep track of sessions, right? When cookies are used to keep track of sessions, and this is the kind of things that can happen. So there are some mitigations for this. Like for instance, the server should basically use origin check, right? Like the bank, for instance, should say, where is this request coming from? It's coming from my.hack.com. That should not be possible, right? Instead, what should happen is that the bank should be saying that the referrer on the origin should be hdfcbank.com, right? Only a form filled on hdfcbank.com, right, should be allowed to access hdfcbank.com/send me money, right? It can't come from somewhere else, right? That's a very good way to mitigate this specific check on the server, right? The other thing that can happen is what is called anti-CSRF tokens, right? So these are tokens. So you can see this token value here. What the bank does in their legitimate form, a bank's real form. So this is, you can see this is HDFC Bank's own form, right? In the bank's own form, they will always have a CSRF token, right? In the CSRF token, what would happen is that this token has some value, right? We don't know what this value is. It just looks like a random set of characters to us, but the bank understands this token, right? Now, a hacker's website, on the other hand, will not have this token because this token is a very, very short-lived one that can, for every time you reload the page, you will get a different token, right? Every time you reload the page, you will get a different token, right? But a hacker's website will not have a legitimate token, right? My.hack.com will not have a legitimate token, right? In that case, if they were to set up a hidden form like this, and then issue a request to the bank to transfer money, the bank is going to reject it because there is no CSRF token, right? And even if some value were there, that is not a value that was issued by the bank itself. So the bank is then going to drop this request, right? So this is a way to mitigate a CSRF attack. Okay. Another way to do this is by setting the cookies correctly, right? Do not use open cookies, right? Now there is values called same site in the cookie. So you can go again, let's go to Burp Suite, right? You can see in this cookie that Google set, it set same site equal to none, right? Which means that the Google cookies can be used outside of Google. But here, right, you can set the same site to be strict, right? If you set the same site to be strict, then you can only access a cookie if the page was also on the same website, right? And it has to be, you can't do a CSRF. You can't basically have my.hack.com send a form request to the bank.com, right? And then have the cookies be sent to bank.com. That doesn't work, right? You have to be on the bank website. You have to submit a form to the bank, and the cookie has to be from the bank itself, right? So same site equal to strict will prevent this kind of attack, right? There's also a lax mode, which depending on what kind of website you're setting up, there is a strict mode or lax mode will work for you. Obviously, with something like banks, the strict mode is obviously much better, right? So if you can build these kinds of mitigations, you can have anti-CSRF tokens, you can use same site for the cookies, you can do these kinds of values to set this to make sure that CSRF attacks are not happening. Okay, I hope that helps. So let's look at another challenge. This is not a CSRF challenge, by the way, but it's just something that we can look at, right? The inspector challenge. So we're just going to do these three just as an example, right? And then, just for you to take a look. Okay. So there is a challenge here, right? And it says, Kishore Balan tipped us off that the following code may need inspection, right? And so here is the link, right? And there are some hints to this as well. So there's one hint is how do you inspect web code on a browser? The second hint is there's 3 parts. That's good. So we actually got to see some hints. So let's go click on this link, right? And it says inspect me, right? What? I made a website. How? I use these to make this website, HTML, CSS, JavaScript. Now, how do we look at this, right? What do we do to solve this challenge, right? It's an inspector challenge, right? And it says that there are 3 parts. So if you go back, the hints basically say there are 3 parts. And how do you inspect web code on a browser? That's interesting, right? So we know how to look up, all this data on a website. So we already did this once before. So in the browser, we're going to go look up the web inspector, right? If I go look up the web inspector, it's currently on the cookies page. Let's go back to the elements, right? Now on the elements, you can see there's HTML, right? So let's go to this. So there is the head part, right? And then there is the body part. And then there is also all the JavaScript part, right? All of these elements that are there, right? We can look up the sources, right? The sources basically say, all the different parts that are there are listed out. So for instance, here's, these are all the different pieces. This is the website itself. There's CSS. So we looked at this, right? There's fonts that you can go pull from somewhere. In this case, it's the Open Sans Roboto font that was pulled, right? Then there is the CSS, which is a style sheet, and then the JavaScript, and then the actual web page itself. So let's go take a look, right? This is the web page. It says my first website. And then there is a bunch of stuff, right? Script type is this, body is so on, so inspect me, and so on. And it does all of these things, and HTML is neat. Anyways, have 1 of 3 of the flag. Hey, look at this. So there's 3 parts, was one of the hints, right? The first part is right here, right? This is one part of the flag, right? I will leave you to find part 2 and part 3 of the flag. Remember, there are 3 parts. And the website clearly says, what was used to build this website. So it should be easy enough to go figure out from there on what the rest of the flags are. Again, not a CSRF challenge, right? Just an interesting challenge. Okay. Now let's take a look at something else, right? This is XSS, cross-site scripting. So we looked at CSRF is one kind of attack, right? Cross-site request forgery. The second one is cross-site scripting, right? Now, cross-site scripting is a very interesting attack, right? This is actually a code injection vulnerability. So CSRF was more about cookies and more about using a logged-in session to take some action, right? You're already logged into a website, and then the CSRF was used to take that already logged in website and take some action on that, right? Now, in the case of XSS, it's actually a code injection vulnerability, right? What this means is that I am going to inject some code, right? Typically JavaScript, right? I'm going to inject some code into an existing website, right? Now, how can I do that? I mean, the website is running on a server somewhere. I'm sitting somewhere else, right? I'm using my browser. The server is sitting somewhere else. How can I inject my code into the server, right? Now, this means that the server must accept some data from me, right? If the server accepts some data from me, then I can basically use that part, right? Wherever the server accepts data from me, I can use that to send some code that the server will then run, right? So in this case, typically what happens is that it is going to be either a form, right? A form is one of the places where I can write some information that the server is going to accept from me, right? Or we have seen it in the URL itself, right? We've seen a get request with some bunch of stuff in the URL and some argument, and then in the argument I can give some information, right? These are two ways in which I can basically give information to the server that the server can potentially execute, right? So let's take an example, right? So this is an insecure website, right? It's basically going to say, give me an employee information for this employee ID. Right? And I can say 1, 2, 3, 4, 5, for this employee ID of 1, 2, 3, 4, 5, give me the employee information, right? This is what happens, right? What happens is inside the web page, right? This is basically, it's going to go look it up and then say, from this request, right? I made a HTTP request, right? From this request, get this parameter EID, right? So I hope you can understand this, right? What I'm doing is from this HTTP request, get this parameter, which is the EID, which is 1, 2, 3, 4, 5, right? And then it's going to print this information. It will say employee ID is whatever this employee ID is. It's going to print this information, right? Now think about it, right? It's asking me for some information. I'm giving that information, 1, 2, 3, 4, 5. But do I have to give 1, 2, 3, 4, 5 only? Do I have to give only numbers? What if I give all kinds of other information? What other kind of information can I give? I look at the web page and I can clearly see that it is taking this employee ID from the request and it is printing it back, right? Now, what can I do so that I can get this EID, whatever it's printing, to execute some code, right? And the kind of code that typically gets executed is JavaScript, because you're actually asking the browser to execute code. The browser is typically executing JavaScript, right? So what I'm going to do is I'm going to, instead of 1, 2, 3, 4, 5, what if I give a JavaScript code there, right? Will this get executed? That is something that we can experiment with, right? So I'm going to do this. In this insecure example, I say print employee, and then I say employee ID is some JavaScript code, right? Look at this. I'm actually asking for the document.cookie, right? I'm asking for a cookie, right? And saying, instead of giving 1, 2, 3, 4, 5 or some number or some text and all this stuff, I'm actually giving an actual code here, right? So I do this, right? I do this. Now employee ID, and then it is going to do all of this stuff. Now, what is a browser going to do? Right? The browser is going to look at this, it'll print employee ID, it'll look at this and say, hey, there is a JavaScript here. Let me execute this JavaScript, right? So it's going to execute the JavaScript, and then this is what I get. Because I used an alert, right? It's using an alert, and the document.cookie, the cookie is actually a token with this value. That's the cookie, right? It's a token with this specific value. This is what will happen. Now here, I use a simple thing by saying alert, right? But in reality, it's JavaScript, right? I can basically have it execute anything. I can have the document.cookie sent to me, right? I can have the document.cookie be filled in a form somewhere, or is sent to my website, or do all kinds of things, right? So basically what I just did is that I found out that this website takes some information that I can give it. So let's go back and take a look again. It takes some information that I give and just prints that information on the web page, right? Now, it is not sanitizing that information. It is not checking to see that information is a number, a string, a code. It's not doing any of the checks, right? It's not sanitizing the information. So in that case, if I give it some script instead of a number, it will simply print that script, right? And it'll ask the browser to just print it. The browser is going to look at it and say, hey, it's a script tag. Let me execute it, and it'll execute it. That's a cross-site scripting example, right? An XSS example is exactly this, right? So this is how I can inject code into somebody else's website because they are asking me for some information, employee ID. In this case, they're asking me for some information, and then I am going to give them a JavaScript instead, right? And they think they're going to print that information when in fact they're going to end up executing that code, right? And this is what's going to happen. It's called a reflected XSS because whatever I give is reflected in the website directly, right? It's not stored in the database or anything like that. It's just whatever I give just comes back, but it comes back and is getting executed, right? So it's called a reflected XSS example. Okay, how do I deploy this? Exactly the same way, same thing, right? I sent a phishing email. I have this form. It says complete this form. There's a link here, except that this link is basically, full of, it has some JavaScript in there, right? So I basically give this link here, right? Whatever link I gave here, right? There's all of this stuff, right? And you saw that is in the previous slide. You basically said print employee ID, blah, all of this document. That is what this link is going to be, right? This link is going to be that, and as a result of that, I'm going to get the cookies out of that. That's how I can deploy this thing, right? So another kind of XSS is basically I realize that some information that I specify is inserted into the database of the server, and anybody who goes to that server and looks it up, it's going to pull that information out of the database and give it to that user, which means that now I can have some JavaScript code being executed for all users who access that database, right? This is typically used in comments. Let's say I go to some web page, let's say a news web page, right? I go to the news web page, there's a bunch of news, and then it says, you can provide comments, right? Provide comments, and then they have your name and some box for comments, right? In the box for comments, right, I can basically, what if I do some script and put some bunch of JavaScript in there? What will happen is that comment will now get saved in the database. Another person comes, right? They come and they go to the same news website. It's going to show the news, and then it's going to take the comment out of the database, and then it is going to print that comment in the database. But the browser is going to look at it and say, hey, there's JavaScript there. Let me execute it. And so some other user, right, who visited that website is going to see my JavaScript executed, right? Not just one user, but let's say thousands of users who are going to go to a news website, right, are all going to see my JavaScript executed there, right? Which means now I can have access to the cookies of thousands and thousands of people who visit a news website. They did nothing wrong. They didn't even receive a phishing email, right? Nothing. They just simply went to a website where I injected some code, and that code was stored in the website's database, right? As a comment, as a forum message, and all that kind of stuff. I simply put some JavaScript that got stored into the database. Now, thousands and thousands of people whom I did not even have to go target with a phishing email, they simply visited that news website, and now I have access to their cookies, or not just cookies, anything that I want to get from them, right? That's a stored XSS. You can see how powerful this technique is, right? I don't have to go target thousands of people. I just have to go target some website which is incorrectly written, which does not sanitize their input. So an example, right? I give a username, right? In that username, I just specify this as a script, and then I do submit. This username is now going to get stored in the database, right? Now somebody else comes and visits the news website, right? They're going to see comments from me, and my username is going to be JavaScript, which the browser will execute like this, right? It's basically going to say this is the, this is basically the server, right? It's basically creating a database connection and then executing a query saying select, from users where some IDs, some name, right? And then it's basically going to say, okay, get the name and print the name in the comment section. When it prints then this name here, my JavaScript here is going to execute, right? And then I'll see a hello. The users will see a hello. Anybody who visits that website now is going to see whatever JavaScript that I put in there. They're all going to get executed. This is a very difficult one to get rid of because remember my JavaScript code is now stored as a comment in the server of the news or any website, right? Any website that text take comments is stored in their database, right? They have to go back and clean the whole database of my comment first. So that's how this works. Okay, let me show you an example of this, right? So I have some code. Right? So that's running. And in fact, so I have some code that I have running where I have this specific, okay, you can see, there's a small piece of code that is there that is basically taking some name, right? Some hello, and then it's basically doing this, right? And it's not doing anything at this point. But what I'm going to do is I'm going to take this and I'm going to, I know I wrote this code. I can just go look at it and say, let me say name equal to, right? And then I'm going to say script, alert, like this. This is a reflected XSS, right? When I do this, right, it goes to that website. And is my server running? Sorry, I need to see if my server is running. Yeah, okay. So in this case, right, I basically went to my this small application that I wrote, right? Hello, and then, yeah, I made a mistake actually. Let me go back and change this. This is question mark. Question mark. Let me redo this again. So I'm going to say hello, and then that hello thing then takes a parameter called name, right? In that name, I'm going to say script. Yeah, so this, like this. So you can easily create these kinds of applications, right? And then just says hello, and I'm going to say script and all of these, right? And hit enter. When I go to this, it says hello. But instead of saying, all of this, alert and all these things, I can basically say, give me cookies, right? Or I can say, give me whatever, right? Or I can say, send me a message to this thing. Remember, it's all JavaScript, right? So if you find a website that basically takes a parameter, right? One of the penetration testing that, that you will try to do is basically this, right? So in your CTF challenge, think about that, right? In your CTF challenge, it's possible that one of the challenges could be that something like this, right? And where you can use XSS to do something, or CSRF to do something. So, okay, I think I did see some answers, right? And here that said 18. So if you go back to this cookies challenge, and I set values 18, and then I do this, it gives me the Pico CTF. I take this and I put it in the challenge, and that's that. Okay, let me show you one more interesting thing, right? We're going to use Burp Suite, and we have the Burp Suite browser, right? Now Burp Suite has sample websites, right? To in order for Portswigger has a bunch of web security academies and things like that. You can go experiment with it. Let's take a look at one of them. So here is one. Let me go first Burp Suite. I'm gonna intercept is off, right? So that's very good. I went to this e-commerce shopping website thing, right? And then here I want this leather jacket, right? So I'm gonna go look up this details of the leather jacket. Oh, maybe I need to reload. Hang on. Let me reload. Okay. Sorry, 1 second. Let me just bring this up. Okay, so we're here. Oh. Okay. Maybe I need to restart. Sorry, I'm just kind of fighting with some of this stuff. Okay, now let's try this, right? So I want this jacket, right? So I go look up this jacket. It's, so much, costs a lot of money, right? So I look at it, this is great, okay. I want to add to cart, but I want to understand how this add to cart actually works. So what I'm going to do is, remember, it's in this browser. I'm turning intercept on, right? So intercept is on, right? So once intercept is on, I'm going to say, add to cart. Let me see how add to cart actually works, okay? And here you can see the request that was sent, right, from the browser. And there's a post request, right, to this cart, right? There's a host information, there's a cookie was set for the session, bunch of stuff. And then finally, remember, we talked about all different kinds of ways that that you could have a request set, right? So let's go back to that a little bit. I'm going to go and say, post. And yeah, okay, post. Okay, so we looked at the post, right? And we saw this, we saw post, and then there's a host, and then see this field 1 is value 1, field 2 is value 2. So let's look at the shopping cart. It looks exactly like that, right? It looks product ID is 1, redirect is product, and quantity is 1, and price is so and so. But here's the thing, the price is listed here, right here, right? So, okay, can I change this price and send it? Remember, I've intercepted this. I'm acting, this burp suite is acting as a man in the middle, right? So I intercept it, right? And then I modify this request. I'm going to set it as 13, right? And then I forward it to the server, right? This is what I did, okay? Now let's go back. Okay, so I've added it to cart. Now let's look at the cart. Oh, stop the intercept. So let's look at the cart. Now look at the cart, right? It was supposed to be $1337, but instead it is $0.13, right? And that's because this application, this is of course, it's just a test application, right? And this application basically allowed or sending the price as part of the request itself, right? Which means that I can go modify the request and send it out, and in that way I can basically change the shopping cart, right? I can change the price, I can do all kinds of things, right? So again, it really depends on how the websites are written, but Burp Suite and these tools allow you to see how how things work between, you sit in the middle and see how things work between the browser and the actual web application itself, right? And then allow you to modify, allow you to understand how these things work. And when you start doing penetration testing, all of these are definitely very interesting, right? Important to know. Okay, so we looked at a few challenges, and let me go back to the XSS example that we were looking at. Okay, so we looked at this. We looked at the sample application that I had, and so we were able to attack this, right? So mitigation, don't trust the client data. If you're taking any client data, either from the URL itself or from comments sections and things like that, you have to clean it up, right? You have to clean it up and make sure that all script and these kinds, anything that can be executed must be properly cleaned up, right? Clean it up and then store it in your database or print it out. Don't just take a user input and just directly print it out. It doesn't work that way, right? That's not the right thing to do. So this is, we're reaching the end of the presentation, right? So in summary, right, we went through a bunch of things. We went through DNS, right? We looked at dig is the command that you can do on a Linux or Unix-like system. Linux-like system, you can use dig to look at it. We looked at HTTP, HTTPS, and some of the messages get and post, right? We looked at HTML, CSS, and JavaScript, some tools, right? We had looked at Burp Suite, it was very interesting. Curl, of course. We looked at cookies and CSRF and XSS, right? These are some of the items that we looked at. One thing that we did say was, let's go back, right? And this because CTF, let's look at get ahead, right? So we were looking at this. We said, get and post, but there's another kind of message called head, right? Which we did not look at. But the hint actually says that, right? Hint says maybe you have more than 2 choices, right? And typically we only think of get and post, but maybe there are other choices, right? And the choice here is really a message called head, right? And you can go look it up, right? And see how to send a head message to this server, and maybe that helps, right? And that's one of the things that you can do. So you can use like Burp Suite to modify the message and see if that helps, right? You can try it out, okay? So head is the message that you can try. So yeah, so we basically looked at a few challenges. We looked at this thing. We looked at the cookies challenge. We found the answer to that. Inspector is basically how to inspect the code and see it, and you'll see that a lot, right? Not just via Burp Suite. You can even see it in the developer tools and Chrome and so on. You can go look up, what the code looks like. Of course, something like Burp Suite is a lot easier for you to modify and send that information out so that you can play with it real time. With the browser, you can just take a look at it. But with the browser, you can also modify the cookies and play with the cookies and see what happens every time you change cookies and so on. Go through the other challenges that are here. They're all very interesting. You have the 52 challenges in the web exploitation category alone. I think they will be very useful in learning more about how web works, right? And in the next session, we will look at more of the server side penetration testing. So yeah. And so just a summary of web security, because web security has evolved over time, there's a lot of problems that just exist, right? And I think when you start building websites, you have to take a lot of these into account. Like go to OWASP. OWASP is a website that keeps track of the top 10 security problems, how to mitigate them, and so on. When you're building, you need to take care of all of. When you're building applications, you need to take care of web applications in particular. You need to take care of all these kinds of items. As a penetration tester, of course, any website that is not built correctly is obviously, you can play with it and see, in what way are they not built correctly. The only thing I would say is please don't use this for doing bad things, right? I mean, the goal here is to learn about security, but not to do any hacking itself, right? So which is the reason why something like, the CTFs are very, very useful to be challenged, right? I mean, they are very good challenges to learn, right, and do with it. But targeting actual websites is not a very good idea without the permission of the website itself. I mean, if you're an ethical hacker, you are doing a penetration testing as part of the being part of the company itself. Like, let's say the company hired you to check and verify how the website works. That's a completely different thing, right? You're working for the company, you're verifying that the company has built good websites. I think that's a good thing. But hacking a company, a bank, or any other web application without the knowledge of the company itself is not a good idea, right? And it's very illegal in pretty much anywhere, right? So just be careful when you do these kinds of things. Make sure that you focus more on the challenges in CTFs and so on, as opposed to trying to hack something, right? I think that's what I would highly recommend. That's all I had. So
Yeah, Karthik, I hope I am audible now.
yes, you are. Yes, Abhishek.
I'd like to thank all our participants for having stayed with us. We had certain connectivity issues at the start. And I'll begin by proposing a vote of thanks to Mr. Kaarthik Sivakumar. Kaarthik is quite a well-known face in the cybersecurity industry. And believe me, all the participants are quite lucky that they got to understand not only different tools, but also different approaches on how to use these tools. We hope that this will be useful when you negotiate the CTF. So, and we hope all of you have paid attention. We will be providing you the link to the recording of this webinar shortly. Now, I would request my colleague, Mr. Kaushik, to please do the Q&A part. Kaushik, can you please moderate the Q&A? Okay, so I believe Prapanch has already handled the Q&A.
Okay.
It is already moderated.
Okay, fine. So
Almost all the questions are answered by Prapanch in the Q&A.
Okay, great. Thank you, Prapanch. Yeah.
Okay, all right. So in that case, I have now the solemn duty of mentioning about the assessment. It is now 5:18 p.m. So we'd request you to please, I'm going to paste the link to so that is the webinar web page. You can find the assessment link once you go to this web page. So dear friends, you can find the link once you go to this web page, and we will keep it open until 5:20 p.m. tomorrow evening. The recording for this webinar will be available shortly, possibly by around 6 p.m. And we will send you the link to download the same through WebEx. It will be a public link, and any one of you who has the link and the password should be able to access the recording. We request you to please ensure that you're on a reasonably good connectivity when you're seeing the, we request you to please ensure that your internet connection is stable when you're trying to view the recording. And if you view the recording and attempt the assessment, we are quite sure that all of you will score very well. Okay, so there's a question about confirmation of CTF registration. In case you're receiving the emails announcing the webinars, that means that you are registered. We have not sent out individual confirmations because there was a huge volume of registration. There's another question about the level of CTF. There is a pre-CTF session on the 5th of July where all this will be discussed, and that would be applicable only for the top 500 participants who make it there. So we request the participants to please concentrate on the webinars, concentrate on acquiring new skills, learning new tools, and doing well in the assessment. So if that is all, we have pasted the link. I'll do it again. That's the link to the webinar homepage, and the assessment link can be found there.